Alright, so hey guys, it's AxiomaticUncertainty here, and I'm finally back with another video. I know it's been a long time since I last released anything, but I've just been kind of burnt out with making videos in general, so this is going to be my first, venture back into things, so I hope you understand if things are a little bit rough. Obviously, it will be hard to be as, smooth in the pacing as with my previous tutorials, especially the car tutorials, but, hopefully it'll still be alright. And I think it goes without saying that because this tutorial is not a beginner tutorial, I'm not going to be doing as much hand-holding as I did in the original series, so that means also I will not be, helping you with every technical issue in the comments. I just don't have time for that anymore, and I especially don't have time to create more videos that require that from me. So yeah, that's just a quick disclaimer. If you need that kind of help, you may want to go to the other series and kind of get a feel for Unity first, or, check out some tutorials from some other people. But this one's going to involve, a lot more just general knowledge. Okay, so now that we got that out of the way, what we're going to do in this first tutorial, you can probably tell based on the title, is we're going to be working on setting up a basically simulated suspension. We're doing this all without wheel colliders, so the first thing we're going to want to do is we're going to want to create a game object. And this game object is going to be one of our springs, right? So we'll just call these, let's call these FR, or yes, let's just go with the nomenclature that they have here. So we'll do spring FR, right? We'll add this under here, and we'll reset the transform. Scaling doesn't really matter, but I don't know. I just kind of like to do that stuff. So we'll do that, we'll reset it all. And then we will move this back. And we'll copy and paste this a couple times. We'll rename these. So we'll call this one spring RR. And this is going to be our right rear spring, right? So we'll drag this under here. We'll reset these parts. And then we'll pull it out into the main car. And then we'll do the same with these two. So spring FL. And we'll put this one under our front left wheel. We'll reset all this stuff. And we'll put this one back under our wheels. And actually that's interesting. So I think some of these wheels are just flipped, which is why these are ending up with 180. I mean, it doesn't really matter, but it's interesting, I guess. And then for this one, we'll say front right, and we're just gonna reset the positioning. So what this is gonna do is, in the future, we'll move these again because these are obviously not totally accurate suspension locations. But what this does is now we have a series of suspension points. Oh, we didn't rename this one, I think. Where is this one? This is the. Wait, is this? Oh, we didn't do this one, I think. Oh, I put it onto the wrong object. That's what's going on here. This is rear left, so we'll just call this spring RL. And we'll have to reset this because I positioned this one at the front right when I did not mean to do so. Let's just drag this one back under the actual car. And you can see now what we have is, if I click through these, you'll see all these springs are located at their respective wheels. And so what we're going to do is we're going to use these to simulate the suspension at those points on the car. And this is going to be modular, meaning if you decide to do, a semi-truck, in theory, you can do that with this system. So anyway, we're going to now add the rigid body and just basically the physics components of the car. So, rigid body goes on the main car, obviously. I kind of liked the idea of putting the box collider on here, so I guess we'll do that. So we're going to add the box collider to the car body in this case. Obviously, if your model doesn't have a car body, you can do it the other way. It doesn't matter which way you do it. It's just a question of preferences. and we'll just set these up to be a little bit higher. Again, I've talked about this before, you know, sometimes what looks right and what is right, you know, are not the same, and so I don't always go with what's the most accurate physically. But anyway, now that we've added this stuff, if we play this, we should see the car just fall. Yep, okay, and it collides properly, so that's all good. Now what we want to do is we want to start simulating some forces, so we're going to have to write a script for this, obviously, and we'll just call this like our, I guess we'll call this our suspension script. So we'll make a new script and we'll call this suspension. And I don't know why it didn't parent that. I created the script under there. That's weird. Anyhow, we've created our suspension script. Now we're just going to go in here and we're going to start writing some code. So let's just get this open, reload, since it didn't load mono behavior properly. Okay, there we go. So we've got our environment set up, and we're going to need a couple of variables. Now, in the hover car tutorial, somebody did aptly point out that that can be used to make actual cars, and that's true. So that's actually the basic scheme of what we're going to be doing in this video. So we're going to go step by step through building basically a hover car, but with car springs instead of the, you know, electromagnetic thing I was doing with the hover car. So this is going to be a lot more of a smooth suspension like you would see in an actual vehicle. And then in future tutorials, we're going to go through and do things like dampening and stuff like that. So we need a couple variables. The next one we need is the rigid body. Technically, you don't need this. You can do get component if that's what you would prefer. And so you wouldn't need to make the rigid body public in that case. You could just do a get component in the start here. But that's just my personal preference. So let's just add some other variables. So we'll make a public float. We'll call this the max force. That's just going to be the maximum force that the springs can exert when they're fully compressed. And then obviously we have one more variable. Well, maybe not so obviously, but a max distance. In the hover car tutorial, I didn't do that, and I kind of felt like that would have been a bit better. And okay, so since this isn't actually accurate, we're not going to be using update here, so let's just remove this. And we'll add a fixed update function. Whoops. And the fixed update is just going to allow us to make more precise adjustments to this object. You know, basically this will, you know, run more than our actual visible frame rate, and that's going to make things a lot easier for us because we're simulating physics here. We want it to be as accurate as we can, even between frames. So actually we're not going to, I don't know why I was going to add a force right off the bat, but we're going to do a for each loop first. So we'll have a game object. We'll call this spring in springs, right? So what we're going to do is we're going to iterate through our list of springs, and we're going to add a force to each of them. And how we're going to figure out what this force should be is we're going to use raycasting to figure out how extended our suspension is right now, right? So obviously, in a car suspension, the closer the car gets to the ground, the more force it's going to apply upward on the car. So, or I should say downward on the ground technically, but that, you know, is relative. So now what we're going to do is we're going to go in here and we're going to actually perform the raycast. So this raycast hit variable is just what we're going to store the output of the raycast in. If you haven't seen how to actually perform a raycast in Unity, I strongly suggest that you go look at the documents for that. You can find those on the Unity API docs. And that'll really help you with this in understanding what we're doing here and how this works, because it may not be necessarily clear. But we're going to raycast downwards from the position of the spring, right? And we're going to do this in the negative direction, meaning -1 times transform dead up. Now, in the past, I have not used this transform dead up. But what this does is it gives us the, basically the object has an upward direction, that is not world space. And as that object rotates, that upward direction changes, transform.up basically automatically converts it to world space. So if we say negative transform.up, this gives us transform.down for the object. And if you've seen my previous tutorials where we did this differently, this is the equivalent of transform direction, which, as you can see here, transforms from local to world, and then just saying vector3 up, right, and then -1 times this whole thing. But anyhow, let's just get rid of that. Oops. And in here, we're gonna keep doing this. So you can see we're raycasting downward relative to the object, or to the spring. In this case, it's actually relative to the car, but the spring and the car are aligned. If you want to change that, what you can do is you can say negative spring.transform.up, and that'll make it relative to the spring. But I don't really care in this case. But that would be helpful if your suspension is at an angle or something like that. So do keep that in mind. All right. So the next thing we want in this raycast is we want to specify where we're going to output the data to, and we've done that now. We're going to, as I said, use this hit variable, which is a raycast hit, and we're going to store it inside this object, I should say. It's not actually really a variable. And then here we have to specify a maximum distance for the raycast, and as you could probably guess, that's why we have our max distance variable, so we'll just use that. All right, so now that that's done, I want to add a force, right? And the way in which that tends to work is basically the basic car suspension. You can see I pulled up a Wikipedia entry for this. Involves simple harmonic motion of the spring. There's no dampening. You know, you're not accounting for any of that. On a very basic level, this is basically it for the spring, right? So what we have is we have a constant, and this constant is proportionate to basically nothing. It's just arbitrary on the basis of the spring. But the force itself is proportionate to the x value, which is why we multiplied this constant by -x. So basically, what this means is there's an equilibrium point for a spring at which it's neutrally extended. The further the spring extends, or the further the string is compressed or expanded, the more force it's going to apply in the direction of that equilibrium. So basically, that's why it's applying in the -x direction. If we compress it, we're pushing away from the equilibrium. It's going to push negatively relative to the direction in which we compress, and so it's going to push back towards the equilibrium, right? That spring wants to be at equilibrium is the idea. So in our car, basically we're gonna set an equilibrium, kind of. We're gonna artificially set the equilibrium to be the maximum extension of the springs, right? The assumption is that this is the maximum natural extension of these springs. This is the furthest they'll go while applying forces. So our max distance is effectively our spring equilibrium, and what that means is we're going to apply this force relative to how compressed the spring is, and not the actual distance of the hit. So we're gonna go over specifically how we do that in a second, but now what we're gonna do is we're gonna add the force. So the force add force of position has two components. It has the force and it has the position. Our position is going to be the position of the spring, so we'll say spring.transform.position. And then our force is going to be, well, first off, multiplied by our max force, right? So let's get our coefficient in, and then scaled to time.fixed delta time. I don't know why I wrote transform. Time.fixed delta time, right? Because we're in the fixed update function here. And then multiplied by the direction. So in this case, the direction is transform.up. If you want, again, if your springs are at an angle, you can specify spring.transform.up. But right now, we're just going to apply an upward force on the vehicle. And then the last specifier we want is our function that we're going to come up with here. And as I mentioned, so when the spring is at equilibrium, right, we want no force, which means if we're at our max distance, we want the force to be 0, right? So we want to compare our max distance to our hit dot distance, right? If the hit distance is equal to the max distance, we want the force to be 0. So that's what this will do, right? If this is max distance, it's max distance minus itself, which is 0. And then we want to normalize this, so we're going to divide by our max distance also. What this will do is basically it'll make this a value between 0 and 1. When this is 1, we're just going to apply a force at this position equal to max force, and when it's 0, we'll apply 0 force, and it'll scale basically in between. So basically our force can be anywhere from 0 to max force based on the extension. So yeah, now that we've gone over that physics, let's just try it out. We're going to come back in here. We should see our variables sync up, and you can see they're here now. First we'll add our rigid body from the car. Our max force, we'll deal with that later, but I think it should probably be around 200,000. And our max distance, we'll go with 2.5. I'm not entirely sure if that really makes any sense. I have no idea what the average suspension height for a car is, but basically we want our max distance to be about double the suspension height. So, you know, I'm not totally sure what that's actually going to end up being, but, you know, we'll just say that for now, and, you know, we'll figure it out later, I guess. So yeah, now that we have this stuff set up, we're going to test it out and play around with some values for the maximum force and just see how it works. Obviously, we're just going to sort of try stuff until we get a force that makes sense. This might take a while, honestly. It's looking like it will. Oh wait, I think I forgot to, give me a second. I forgot to add our springs, so just remember to do that, because apparently I do not. But yeah, we're going to add our springs here, and what it's going to do, as you saw in the script, is it's just going to iterate through the springs, figure out how far they are from the ground, and then apply a force according to that. So initially the springs are going to be on the ground. We're going to apply a maximum force, and that's a little bit much, it seems like. Okay, yeah, that's way too much force. Oh, you know, I was thinking about 200,000 if we scaled this to 1,000. So let's increase that a little bit and try it out again. All right, you can see we're on the ground. Oh, there we go. We're bouncing, and we're kind of gliding along the surface. Now you can see it looks a bit weird. That's because, one, we just dropped the car, and two, it has no other forces applied to it. But we're gonna sort of go over to the car and just, before I end the video, figure out sort of what a good number is for this force. So let's just bring the car towards the middle and sort of let it settle on the ground. All right, and now that it's settled, we're gonna slowly increase this until this force starts to actually make any sense. Right, so you can see the car is kind of drifting around, which is good. That's kind of what we want. And we're just going to kind of, let's set it down again. We're just going to kind of really slowly and gingerly increase this force until we can figure out precisely where, basically where the wheels are a little bit off the ground. Obviously, you can probably guess, we wouldn't want the wheels to be perfectly touching the ground at all times. Because the suspension is always a little bit extended in an actual car. Great, now we gave it velocity. That's not what we wanted. It's just, whoa, I don't know. Okay, I definitely screwed up the car. Oh, I see what I'm doing. Darn it. That's kind of annoying. I accidentally moved the body instead of the actual car. So that's, anyhow. Let's just figure this out. Okay, that was a little bit of a sudden increase, but hopefully if this thing starts to settle a little bit, we'll be able to figure that out. All right, let's just try to, okay, that was the opposite of the effect that I wanted actually. I'm just trying to get it to settle so I can figure out where this equilibrium height is. Anyhow, you know, this is basically, at this point, it's just a question of figuring it out. Obviously, if you set a different value for this, it'll be a different number that you want to get for the, you know, the equilibrium is less a question of precisely predicting what it should be, and more a question of deciding what you think looks physically right for your vehicle. So yeah, just play around with those values. You should be able to find something that you're satisfied with, just in the way that I am. Just adjust the force, you know, and try to figure out what looks right. And obviously, you know, don't worry if your car is acting like this, you know, really erratic and kind of bouncing like it's a, you know, an inflatable in the ocean or something. In the future, we're going to deal with dampening for the springs and some stuff like that, so this should fix itself a little bit. But yeah, just you know, focus on getting that all set up properly, and yeah, I'll see you guys in the next video. We'll probably deal with, you know, the basics of applying forces to this thing to get it to move, and, you know, stuff like that. So yeah, that was the first video, and I hope you got something out of it. If you did, leave a like, subscribe, all that, you know, jazz, and I'll see you in the next one.